It was a big deal moving my big wheel to LI. Had a backyard, though shit moved slow. Caught a cat on the humble. What's up, kid? Got me memorizing flicks.
Alright, so now for the next concept, still relating to Taylor series and polynomials. So something which we've seen before called error bound. So again, this is kind of like the error bound for, remember Tn, the trapezoidal approximation, the midpoint approximation, and the Simpson one? Yeah, so it's kind of like the error for that. So what we're going to have is our error, let's see. Okay, first of all, hold on, let me write this out so I can give you the background on where the error comes from. So Tn of x, as we know, is equal to f of a, and then plus f prime at a 1 factorial, and then so on and so forth, x minus a to the 1 plus dot 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 all the way up to f to the n a over n factorial, and then x minus a to the n. Okay? So basically, whatever we have here, this is our Taylor polynomial, right? So what we, like, let's say our n is 3, like on our last one, right? So n equals 3, so we stop when all of these n's in the last term are equal to 3, right? So what we're essentially doing is cutting off the fourth term, or the fifth term, I guess that would be, because this is 0, 0, 1, 2, 3. Anyways, we're cutting off the next term. So what we would have, let's say, what if our n were 4? Then we'd have a 4 over here. So then this would all go all the way to f to the 4th of a over 4 factorial times, sorry, got squished here, x minus a to the 4th. So this is all like attached. This would be the 4th term. But if we're only doing it to the 3rd, then we cut off this 4th term and everything that would follow behind it. Okay? So anything from here to the right, because this would be like the 4th term, the 5th term, the 6th term, etc., that's what we're cutting off. And that's where our error comes in. Because then, by cutting the rest of the terms off, then you get less accuracy. Okay? So here's where I was just explaining where the error term comes from. So it's actually going to be, so error, it's going to look similar to what we did before, like I said. Less than or equal to k, and again, I'll explain what k is, times x minus a n plus 1 over n plus 1 factorial. Okay, where k is going to be, let's see, k is like your f to the n plus 1 power, or degree, or something like that, your maximum value at a certain u, and this is absolute value, where u is in between your x and your a, so from a to x. Okay, so what this is saying is that, let's say, well, okay, I'll rewrite it on the next slide, so make sure you've taken down these notes, and then I'll continue on the next slide. So what our error is actually saying is that when we write it out completely, I like to write it like this, as I've said before, f to the n minus 1 max at a certain point within our interval, and then times x minus a n to the n plus 1 over n plus 1 factorial. Okay, so going back to what I was explaining about where this whole error term comes from, is that let's say we were to stop at n equals 3. So let's say we're doing this approximation, okay? And you know how I said we wouldn't include the term that has n equals 4, right? Because that's past our point that we're evaluating. So the 4th term would actually look like n plus 1, so that would be 3 plus 1, right? So that would be, I'm just going to write it out for your visualization. So this, at a certain point, and then we would have x minus a to the 3 plus 1, which is to the 4th, And then 3 plus 1 factorial is 4 factorial. So see how this would actually be our next term if we were to go further and do like T4, right? So this is the thing that we're cutting off, remember? That and everything that follows after it. So anyways, okay, let's do an example of this real quick. So we're going to calculate the error for the following. We're going to do T2 and 2.1, and then where it's centered around 2, so a equals 2, and then f of x is equal to 1 over x minus 1. Okay, so this 2.1, that is our x value. Okay, alright, so let's get started. So our error formula again, error equals, less than or equal to, and I'm just going to write our k, okay, so first of all, 2, that implies that our n equals 2, okay, so our k is going to be f to the n plus 1, so 2 plus 1 to the third, this is our max value of the third derivative at some point within our interval, from a to x, so our interval is going to be 2.1 over here and 2 here. Okay, so this is the maximum, I guess, range that you can go from. And then we have x minus a to the n plus 1, so 2 plus 1 is to the third, over n plus 1 factorial. So 2 plus 1, again, is 3 factorial. Okay, so we know our x, we know our a, we need to find our f to the third. So let's find f to the third. We have f prime of x is equal to negative 1 over all of this squared, x minus 1 squared. F double prime is equal to 2, positive 2 over x minus 1 to the third. And finally, our f triple prime is going to be equal to negative 6 over x minus 1 to the fourth. Okay? So now we can, here's where, I guess this is the most difficult part about these kinds of problems, is finding what that maximum value is. So this is our third derivative, so this is the one that we're concerned with, and we're trying to find what is the maximum value that this can attain on this interval for x, or u, whatever you want to call it. Okay, so let's say we plug in, and this is actually, we're concerned with the absolute value of it, right? Not just whether it's negative or positive, so that doesn't matter. We're just concerned with the biggest value, biggest magnitude that we can attain. So let's try, I like trying the endpoints. So let's see what f triple prime of 2 would be. And this is absolute value, right? So absolute value of that would be negative 6, and then 2 minus 1 to the fourth. And this would actually come out to just positive 6, right? Okay, now let's try 2.1. Okay, so that would be absolute value negative 6, 2.1 minus 1 to the fourth. Okay, and then this would actually be a 6 over 1.1 to the fourth, which is obviously less than 6. So 6 is going to be our maximum value. They're going to plug in here. Okay, so now we have everything that we need to calculate the error. So we're going to get that error is less than or equal to, we're going to plug in 6, right? And then we have x minus a, so that'll be 2.1 minus 2, and to the third, over n plus 1 factorial, which was 3 factorial. And this is equivalent to 3 times 2 times 1, which, as you can see, cancels out with the 6 on the top. Okay, so we get that our error is less than or equal to 0.1 to the third. So, finally, our error is less than or equal to 0.001. Okay, so that's actually a that's a pretty big error, because this is 1, 2, 3. That's 10 to the negative 3, I believe. And sometimes the error will ask you for something even as small as like 10 to the negative 6. But anyways, so that concludes the video on 9.4.
I got time to think.